Download this code from codegive.com, link in the description below. OK, let's dive into a comprehensive tutorial on UV in Python, a powerful and often overlooked library that offers a high-performance, event loop-based approach to I/O and asynchronous operations. I'll cover the core concepts, common use cases, best practices, and provide detailed code examples. This will be quite extensive, so buckle up. What is UV? UV is a Python binding for libuv, a cross-platform support library that provides asynchronous I/O based on an event loop. Libuv is the engine behind node.js, known for its non-blocking I/O model, which makes it incredibly efficient for handling concurrent operations. UV allows you to bring this performance and concurrency model to Python applications. Why use UV? High performance libuv is optimized for speed and efficiency, leveraging OS-specific features for I/O completion, epoll on Linux, kqueue on macOS and BSD, iocp on Windows. This translates to better performance compared to traditional threading or simpler asynchronous approaches. Event-driven architecture UV encourages an event-driven programming style. Your code responds to events, example data arriving on a socket, timers expiring, rather than blocking and waiting for I/O operations to complete. Concurrency without threads UV allows you to handle many concurrent connections or operations without the overhead and complexity of thread management. It's often more efficient than using traditional threads, especially for I/O bound tasks. Cross-platform compatibility libuv is designed to work consistently across various operating systems. UV thus offers a portable solution for asynchronous I/O. Integration with other libraries UV can be integrated with other asynchronous libraries like asyncio, although it can also be used independently. Installation. Install the uvloop library, which is generally preferred over directly using UV, see below, using pip. If you really want to use the lower-level UV package directly. Core concepts. 1. Event loop The heart of UV is the event loop. It's a central dispatcher that monitors file descriptors, sockets, timers, and other I/O sources. When an event occurs, example data is available on a socket, the loop calls the corresponding callback function. 2. Handles Handles represent resources like sockets, timers, and streams. You create handles, register them with the event loop, and associate them with callbacks. 3. Requests Requests are asynchronous operations that need to be performed. They can be I/O operations, reading/writing to a socket, accessing a file, or other tasks, getting DNS information, running processes. 4. Callbacks Callbacks are functions that are executed when an event or request completes. They are the mechanism for responding to asynchronous operations. Using uvloop, recommended. While UV can be used directly, it's highly recommended to use uvloop whenever you're working with asyncio. Uvloop is a drop-in replacement for asyncio's default event loop that uses libuv under the hood. This provides significant performance benefits and is very easy to integrate. By simply calling uvloop.install, you replace asyncio's default event loop with the libuv-based uvloop. Your existing asyncio code will then run with the improved performance of libuv. Example, basic asynchronous server with uvloop and asyncio. Here's a simple example demonstrating an asynchronous server using uvloop and asyncio. Key points. We use asyncio.start_server to create an asynchronous server that listens on port 8888. The handle_connection coroutine is called for each new connection. It uses reader.readline to asynchronously read data and writer.write to asynchronously send responses. Await writer.drain, ensures that all data is flushed to the socket before proceeding. The code gracefully handles potential connection error exceptions. Of loop.install, is crucial for enabling the libuv-based event loop. Using UV directly, less common, but useful for understanding. While loop is generally the preferred approach, understanding how to use UV directly can be helpful for deeper insights. Here's a basic example of using UV directly to create a simple echo server. Key points. 1 uv.loop, * creates the event loop. 2 uv.tcp, loop, * creates a TCP handle associated with the loop. 3 server.bind, host, port, * binds the server socket to the specified address and port. 4 server.listen, 128, self.on_connection, * starts listening for incoming connections, calling self.on_connection when a new connection is established. The 128 is the backlog, maximum number of pending connections. 5 server.accept, client, * accepts an incoming connection, creating a new uv.tcp handle for the client. 6 client.start_read, self.on_read, * starts reading data from the client's socket, calling self.on_read when data is available. 7 client.write, response, * asynchronously writes data to the client's socket. 8 client.close, * closes the client's socket. 9 loop.run, * starts the event loop, which will run until loop.stop, is called, which is not called in this example. The server runs indefinitely until you manually stop it. Explanation of the direct UV example ***. Echo server class *** The echo server class encapsulates the server logic. *** It creates a uv.tcp handle for the server socket. *** It binds the server to the specified host and port. *** It calls server.listen, to start listening for incoming connections. *** The on_connection method is called when a new connection is accepted. It creates a uv.tcp handle for the client socket and passes it to the client handler. Client handler class ** The client handler class manages each client connection. It creates a uv.tcp handle for the client socket. It calls client.start_read, to start reading data from the client socket. The on_read method is called when data is available. It reads the data, decodes it, and sends an echo response back to the client. The close method closes the client socket. Main section ***. It creates a uv.loop, object. It creates an echo server object, passing it the event loop. It calls loop.run, to start the event loop. Important considerations when using UV directly ***. Error handling * always check the error argument in callbacks. A non-zero error code indicates that an error occurred during the operation. Buffering * You might need to implement buffering to handle partial reads/writes, as shown in the example. Libuv does not guarantee that all data will be read or written in a single operation. Memory management * Be mindful of memory leaks. Ensure that you close handles and release resources when they are no longer needed. More advanced UV concepts and use cases. 1 timers * 2 file system operations * UV provides asynchronous file system operations, reading, writing, etc., but they are less commonly used directly because Python's standard library asyncio provides adequate file I/O functionality that integrates well with asynchronous code. 3 DNS resolution * 4 child processes * Best practices. Use of loop with asyncio *. As mentioned earlier, this is the recommended approach for most use cases. It provides the performance of libuv with the convenience and ecosystem of asyncio. Handle errors. Always check for errors in callbacks and handle them appropriately. Avoid blocking operations. Never perform blocking operations directly in the event loop. This will prevent the loop from processing other events and can lead to performance issues. Use loop.run_in_executor or a thread pool for CPU-bound tasks. Resource management. Properly close handles and release resources to avoid memory leaks. Keep callbacks short. Keep your callbacks as short and efficient as possible to minimize the time spent processing each event. If a callback needs to perform a long-running task, offload it to a separate thread or process. Consider context vars. Python context vars are a good way to manage state information in asynchronous code. Use asynchronous libraries. Use asynchronous libraries like iocp and iopage in your asynchronous code when possible. Example, integrating loop with iocp. This example demonstrates how to use loop with iocp to perform an asynchronous HTTP request. iocp is an asynchronous HTTP client/server library that works well with asyncio. Conclusion: UV, especially through loop, provides a powerful and efficient way to build asynchronous applications in Python. By understanding the core concepts of the event loop, handles, requests, and callbacks, you can leverage UV to create high-performance, concurrent applications that are well suited for I/O bound tasks. Remember to always handle errors and follow best practices for resource management and performance optimization. While directly using the UV package is less common, understanding its internals is extremely useful to better understand Python's event loop and asynchronous programming in general. Using loop is the most practical approach.